Hello, my name is Fernando Tucci and I am a Senior Technical Support Engineer in the team in charge of supporting the automated solutions for PSO within VMware. In this session we will be talking about the latest vSphere version, which is version 6, which was released on March this year, 2015. We will cover what's new and what has changed since the previous version, which was vSphere 5. The topics we will cover today include a brief talk about the architecture, which is a description of the elements that compose a vSphere 6 deployment compared to a vSphere 5 deployment. We will also talk about the hardware requirements and what has changed since the previous version. We will touch on the best practices for deploying a vSphere 6 environment, what is supported and what deployment methods are now deprecated and won't be supported from now on. And we will discuss the new features included in vSphere 6 and how features from vSphere 5 were improved upon. And for last, I have included a lengthy list of resources that should cover all the topics that we're touching on this presentation in case that you want to expand your knowledge on them. So let's begin. The first subject that we will touch is the architecture. The architecture has changed significantly from vSphere 5. There are new concepts, there are new elements, and the philosophy behind this is to avoid the duplication of components and to be better organized and to facilitate the synchronization between different sites. Before we begin to talk about vSphere 6, let's have a quick refresher and a recap of how things were done in vSphere 5. So in vSphere 5 we have four major components. We have the web client, the inventory service, the SSO server, and the vCenter service. All of these could be installed in their own individual virtual machine if you preferred, or you could group them and install them all in the same virtual machine, as it was the case of the simple install. If you wanted to have different sites, you would have to have a different installation of all these components. In vSphere 6 instead, we have two major components which have all the elements from the previous version as well as the new ones, and are organized depending on whether they can be shared across multiple vCenters or not. First, we have the platform service controller, which has the elements that can be shared. So we have the likes of the SSO server, the licensing server, and the VMware certificate authority, which is a new component that we will cover on later. So we have them all grouped in a single node installation. The second component is the management node, which includes all the elements that are singular for an instance. As an example, we have the web client, the inventory service, the vCenter server, and all the individual tools like the syslog collector, syslog server, the dump collector, so all the individual bits and pieces that are peripheral to vCenter server. Like in vSphere 5, we can have the installation embedded, so we have everything, both the platform service controller and the management node, all in a single VM. Or if we prefer, and especially if we have more than one site, we can have a VM with the platform service controller installed alone, and then different VMs with the different management nodes installed, all of them talking to the same platform service controller. This allows us to cut down on unnecessary installations of components and simplifies administration. Now we will talk about the hardware requirements and how does it compare with vSphere 5. So like in the previous versions, the actual hardware requirements depend on each particular site and what the demand for resources is. For the purpose of this slide and for the comparison we will talk about the bare minimum requirements and how it compares with vSphere 5. vCenter Server requires a 64-bit operating system, so we're talking about Windows Server 2008 SP2 and above. And also we'll need a 64-bit system DSN installed for vCenter Server to connect and communicate with external databases in case that you're not using the embedded Postgres database. These operating systems must also have MSI version 4.5 or later installed. This is just mentioning it because anyway, all operating systems starting with Windows 2008 SP2 and above should have that version installed by default. So compared with vSphere 5, there is really no changes here. It's the same requirements for the installation of vCenter in case that you're installing it in a Windows box instead of the appliance. For memory, the requirements change depending on what deployment type you chose. If you're installing just a platform service controller, the minimum is 2 GB of RAM. If you're installing a management node standalone, The requirements rise to 8 gigabytes or higher depending on the type of installation you choose. When you're installing a management node, you have the option for a tiny environment, small, medium, and the requirements rise accordingly. For the embedded installation, so the one that combines the platform service controller and the management node, you add the two requirements together. So for the bare minimum installation, so a tiny management node and the platform service controller, you will be talking about 10 gigabytes RAM required. The minimum requirement for vSphere 5 was 12 gigabytes, so it's a little bit less on vSphere 6. For the disk space requirements, if you're installing just the platform service controller, that would be at the very least 4 gigabytes of disk space. If you're installing vCenter Server management node or the embedded version that includes both the platform service controller and vCenter Server, that goes up to 17 gigabytes. vSphere 5.5 recommended 40 gigabytes of space available, so that has gone down significantly as well. CPU requirements is the only one of the requirements that actually has gone up since vSphere 5. If you're installing just the vCenter Server management node, you will need 2 CPUs. If you're installing just the platform service controller, that is also 2 CPUs. If you're combining them in a single node, however, that is 4 CPUs. So again, you add them, same as we did with the memory. For vSphere 5.5, the requirement was 2 CPUs. So as we said earlier on in the presentation, the hardware requirements really haven't changed all that much. I should also mention though that the external databases supported are Oracle and Microsoft SQL Server for the Windows installation and only Oracle for the appliance. Support for Oracle databases on both the appliance and the Windows installation will be deprecated soon, however, so just something to keep in mind. Now we will talk about the deployment best practices, which is what are the supported deployment scenarios and which ones are no longer supported or have been deprecated. Hopefully this will clarify some of the misinformation and confusion that there was earlier on during the pre-release speculation. So, as we have discussed so far, there are two deployment models that are supported with vSphere 6. One, where the vCenter server has an embedded platform service controller and it's all packed up in a single VM, or with an external platform service controller in which the management node elements are separated from the platform service controller elements, so these can be used by multiple management nodes. Both of these deployment models are supported both in the appliance and in the Windows installation. So let's talk briefly about the vCenter server installation with the embedded platform service controller. This type of installation is sufficient for most environments. It is easier to maintain and deploy. It is recommended only when you're going to be using a single vCenter server and supports external or embedded vCenter databases. And it's available both for the Windows and vCenter Server's appliance, like we mentioned before. The vCenter Server installation with an external platform service controller is better fit for larger deployments with numerous vCenter servers. It reduces the infrastructure compared with vSphere 5 by sharing the platform service controller across different vCenter servers. As mentioned, it is recommended that you use it with 2 or more vCenter servers. It also supports the embedded or external vCenter database, and it is also available both for the Windows or the appliance installations. So now let's talk about the recommended topologies, which are the officially supported methods for deployment of vCenter server and platform service controller in vSphere 6. The first 2 methods of deployments are the most basic ones and are the ones that we have already covered. The first one is when you have a single vCenter server with its own platform service controller and therefore a single sign-on domain and your own vCenter database. Like we discussed before, it is fit for most environments really, unless you have a really big environment or you have multiple sites that need to be served separately. Also, we have the most basic non-embedded method, which is again a single platform service controller and therefore a single sign-on domain and 1 or more vCenter servers connecting to this platform service controller. There is no point really on using it with a single vCenter server unless you're perhaps planning to expand in the future. But if you are for the foreseeable future using a single site, then you're better off just going with the embedded installation. I should mention too that for non-embedded deployments, you cannot install the platform service controller and the vCenter server simultaneously. You have to do it in a sequence. So you first install the platform service controller, then the vCenter server. Another supported deployment method is where you have a single sign-on domain, but that is composed by 2 or more single sign-on sites. So in other words, you have more than one platform service controller. You can have up to 8 platform service controllers in this manner that are part of the same single sign-on domain. And each platform service controller would have their own vCenter servers. Another supported and recommended topology is to have your different platform service controllers behind a load balancer. In this type of deployment, you would still have one single sign-on domain, even though you have 2 or up to 4 platform service controllers behind the load balancer, and you would have all your vCenter servers just hitting the load balancer and talking to any of those 4 platform service controllers. At the time of this recording, there are only 2 compatible load balancers available for vSphere 6 platform service controllers, and that is Citrix NetScaler and F5 Networks Big IP. Apache is no longer supported. Now we're going to talk about the deprecated topologies, and these are the methods of deployment that are no longer going to be officially supported. The first unsupported method is having an embedded installation synchronizing with another embedded installation. That is not going to be officially supported anymore. The second one is having an embedded installation synchronizing with an external vCenter server. So using the platform service controller of the embedded installation for a standalone vCenter apart from the one that comes embedded, that is also not supported anymore. And for last, using an embedded installation with an external platform service controller that is linked to the one that is in the embedded installation, that is also not supported. So what is the common element? As you can see, the common element is the embedded installation. There is really no supported method of linking the embedded installation with anything else. Therefore, the takeaway here is, if you're going to be using the embedded installation, it should be only in the case of having a single vCenter server. If you're going to be using 2 or more vCenter servers, then you want to use the separated installation where you have your platform service controller and your different vCenter nodes. This is something that was communicated relatively recently. In some of the pre-release stages, it was communicated that you could mix and match as much as you wanted to, and perhaps in the future they will again support these topologies, but at the time of this recording, these are the ones that are listed as unsupported. I recommend that you have a look at the KB that lists the supported topologies. This one is included in the resources section at the end of the slides. Now we're going to talk about the new and enhanced features. So we're going to see what has been introduced for vSphere 6 and how the existing features from vSphere 5 have been improved for this new release. So let's begin by talking about the virtual machine enhancements. With vSphere 6 there is a new hardware version for VMs, so it's hardware version 11, and largely what we can see is that most of the maximums were increased at least by double. So as an example, in version 10 hardware you could have up to 64 vCPUs. In version 11 now you can have 128 vCPUs, maximum of course. In version 10 you could have 1 terabyte of RAM, and in version 11 you can have up to 4 terabytes of RAM. Accordingly, you can have 1 terabyte of swap memory on version 10, and you can have 4 terabytes of swap memory in version 11. Another big change is you could have only 4 serial ports per VM on version 10, while in version 11 hardware you can have up to 32 serial ports per VM. Now we're going to talk about the enhancements to hosts and clusters, so to the maximums that ESXi 6 offers compared to ESXi 5. As we can see, there is a big improvement here as well. In ESXi 5 we could support up to 320 logical CPUs per host. In ESXi 6 we can support up to 480 logical CPUs per host. In ESXi 5 we could have up to 512 VMs per host. And in ESXi 6 we can have up to 1024 VMs per host. In ESXi 5.5 we could have only up to 4 terabytes of RAM per host, and in ESXi 6 we can have 6 terabytes of RAM per host. In ESXi 5 we could have 32 hosts per cluster. Again, we have double here in ESXi 6 We can have 64 hosts per cluster. ESXi 5.5 supports up to 4,000 VMs per cluster, and ESXi 6 supports up to 8,000 VMs per cluster. There are a few other improvements, like a change that was made to the lockdown mode. Now there are two types of lockdown mode. The first one is normal lockdown mode, in which the DCUI access is not actually stopped, and users on the DCUI.access list can access it. The other option is strict lockdown mode. In strict lockdown mode, access to the DCUI is completely stopped. However, you can set up a few exception accounts that work even if you have strict lockdown. But you should bear in mind that these are meant for services or applications that need to have access to the host, not really for actual users to be logging in. There is now a setting also to specify the password complexity rules. So with this, you don't have to manually go and edit the file for the password complexity rules. You can do it through a setting instead. There are also quite a few new features that improve the account management and auditability. As an example, now there are ESX CLI commands for local users, where you can add, list, remove users. And also you have account lookup parameters that you can specify. And more importantly, you have better auditability, as I mentioned. And by this I mean that actions from vCenter, actions that are done through the vCenter client, show the name of the user along the log entry. If you remember, or if you have looked in 5.5 when you're looking at the logs in a host, you will see that all actions were happening from the VPX user. So who actually sent the action from vCenter is impossible for you to tell from the host. Now the host logs will actually record which user sent that command through vCenter. That is extremely useful for audit purposes or to see what happened, especially if you don't have access to vCenter at the moment. Platform independence has also been enhanced for vSphere 6. Now, as an example, you can have the VApp management node in linked mode with a Windows installed management node. They also both scale identically, so there are no differences in what they can do or they cannot do. There is only one difference, and it's listed there, and it is that the VApp doesn't support Microsoft SQL external databases. At present, it only supports the embedded vPostgres database and Oracle. It should be noted that the Oracle support will also be deprecated in the near future. I should also mention there are no plans to add Microsoft SQL support for the appliance. So the appliance will only support, in the future, only the vPostgres. We mentioned this in the previous slide, but now linked mode has been improved. So it is automatic with any management node that is synchronized with a platform service controller. So you can have a mix and match of appliances and Windows installations, and they will be in linked mode as long as they are talking to a platform service controller in the same single sign-on domain. So vSphere users in the past have been very reluctant to move away completely from the Windows installed version of the vSphere client, and this was in part because the performance of the web client left much to be desired. So VMware listened to the feedback, and with vSphere 6 there were several improvements done to the web client. Now if you try it, you will see that it has much faster logins, which was one of the complaints of how long it took to log in. In general, it is much more responsive, especially the right click menus are not as delayed as they used to be in the old 5 version. Also, it has a few limited customization options. You have some dockable elements that allow you to move things around and make them look more like you want to. It's not much, but it definitely helps customize the GUI as you want. The feedback from those that have tried it is extremely positive. I am quite impressed with it myself. The vMotion feature also saw quite significant improvements. As an example, now we can do cross vSwitch migration or cross vCenter migration, which means that now we can move a VM from the appliance vCenter to a Windows installation vCenter without any disruption. Before, you could do it with some difficulty, but you would lose all the historical data. Now you can do it as any other vMotion without losing any data. Support for long distance migrations was also added in vSphere 6. What this means is it supports maximum round trip of 150 ms. Just for comparison, in vSphere 5 the maximum round trip that you could have was 10 ms. Anything higher and you would have the vMotion job fail. Now with the round trip being 15 times larger, it allows you to do migrations from sites that are more distant from each other without the task failing. vMotion for VMs that have physical compatibility mode RDMs was also introduced in vSphere 6, opening a few interesting options, one of which we will discuss in a moment. Support for Microsoft clustering was also introduced in vSphere 6. As I mentioned just in the slide previous to this one, support for vMotions of VMs that have physical compatibility mode RTMs is now allowed, which was one of the blocking factors for supporting vMotion of Microsoft cluster machines. Also now it fully supports IPv6, and also paravirtual SCSI adapters are now supported for Microsoft cluster machines. This allows a significant improvement in performance under certain conditions and workloads. The fault tolerance feature also saw a few enhancements. The most significant perhaps is now it supports VMs that have up to 4 vCPUs, while in the past it only supported VMs with 1 vCPU. Memory remained unchanged, but for virtual disk types a few options were introduced. In vSphere 5.5 we could only use eager zero thick disks. Now in vSphere 6 we can use thick, thin, and eager zero thick. The storage redundancy for fault tolerance machines was also improved. Now it allows you to have separate VMDKs for the duplicated machine, so they are not pointing towards the same disk files. This means that if the failure happens at storage level where the disk files were stored, you will always have another copy of the disk files available. In 5.5 instead, it was always pointing towards the same disk files. Support of paravirtual devices for fault-tolerant VMs is also now included. The number of VMs that can be protected by fault tolerance remain the same, but there is an additional condition to keep in mind. Before, in 5.5, you could only support up to 4 fault tolerance protected machines. In 6, you can have either 4 VMs or 8 vCPUs. So in other words, if you have 2 VMs and each of these VMs have 4 vCPUs each, that is your maximum. So it's either 4 VMs or 8 vCPUs, whichever you reach first. The bandwidth requirement also went up from 1 gigabit per second to 10 gigabit per second. I should mention that the mechanism for fault tolerance in vSphere 6 is completely different to the mechanism in 5.5. 5.5 used what was called vLockstep, while vSphere 6 uses what is called fast checkpointing. We won't go into more detail here due to time considerations, but it is something to keep in mind, and in case that you want to investigate it on your own later on. A new feature that was introduced with vSphere 6 is virtual volumes. You may see them referred to as vVols. So what are vVols? In short, vVols offer per VM management of storage that helps deliver a software-defined data center. So how does it accomplish this? Well, let's explain a little bit of the traditional paradigm and see where vVols fit in. Traditionally, storage uses device-centric silos with the typical gold, silver, and bronze tiering. And the problem with these structures is that they have specific capabilities that we tie the workloads to. This is to say that all the capabilities are defined by the structures and then inherited by the workloads. So as an example, if for one reason or another you have a VM that actually has very weak storage requirements and it ends in the gold tier silo, those resources would be effectively wasted. vVols turn this upside down and let the workload request certain capabilities through the policy definitions, and then the software-defined data center intelligently places that workload where it will get the features that it requires, but nothing else and nothing more. Also, it helps by offloading certain processes, like as an example snapshotting or cloning, to the storage array, thus making them faster. Unlike traditional LUNs and NFS-based vSphere storage, the virtual volumes functionality does not require pre-configured volumes on the storage side. Instead, it uses a storage container, which is a pool of raw storage capacity or an aggregation of storage capabilities that a storage system can provide to virtual volumes. The storage container logically groups virtual volumes based on management and administrative needs. HA in vSphere 6 also saw a few significant improvements. The first one is a little bit of a given, but it bears mentioning that machines that use vVols are fully covered by HA. There is also a new feature that allows you to register VMs that are not covered by HA onto another host after a failure. Basically what this means is that when you have HA disabled on a specific VM, this feature will make sure that the VM gets registered on another host after a failure. This will allow you to easily power on that VM when needed without having to manually re-register it yourself. Of course, if the VM is not protected by HA won't power it on automatically. It will just take care of the registration part. Another big change that is introduced for high availability in vSphere 6 is the Virtual Machine Component Protection, or VMCP. VMCP is a mechanism that allows HA to sense APD, or all path down conditions, or PDLs, or permanent device loss conditions, for block and file storage. So to understand what this means, we probably will have to explain first what each of these mean. PDL, or permanent device loss, more or less indicates that the storage device does not expect the device to return anytime soon. In this situation, the VMs will be restarted immediately. For APD, or all paths down, this is a little bit different. APD is more of an unknown situation. The storage may return, it may not, and there is no clue of how long it will take before it comes back. So VMCP allows you to specify a timer, which is 3 minutes by default. If the storage device is still in an APD status after that timer expires, then HA will restart those VMs. The last change is more of a consequence of the increased capacity for the vSphere 6 clusters, but now that we have a greater number of hosts and VMs, this also means that we have a greater HA cluster size. Another new feature is the ability to create multiple TCP/IP stacks to assign to the different vSphere services. A use case for this, as an example, would be to assign a particular TCP/IP stack with its own default gateway or routing table to the vMotion network, thus allowing vMotions to happen across a layer 3 network. Each of these is a fully integrated stack, so they have their own ARP table, their own routing table, their own default gateway, and their own memory heap. SSL certificate management saw a few improvements as well. For one, certificates are issued to a solution user rather than a service now. This means that services that use the same solution user can use the same certificate, thus reducing the number of certificates required. If anybody here has gone through a process of replacing certificates manually with CA signed certificates in vSphere 5, they would know that it was quite a cumbersome process. The process has been quite significantly streamlined and made easier in vSphere 6. A certificate store component was also added, which is the VECS or VEX. The certificate store serves as a local or client-side repository for certificates, private keys, and other certificate information that can be stored in a key store. Also, vSphere 6 introduces its own certificate authority in the form of the VMCA. The VMCA is included in the Platform Service Controller node, and it serves as a full root certificate authority. It can be, of course, configured to work as a subordinate certificate authority, so it can issue subordinate certificates to an organization's root certificate, or if you don't want to use the certificate authority, you can always use your own external certificates, so the use of VMCA is not mandatory. Alternatively, you can also use a hybrid option in which you can use VMCA issued certificates for the internal components and certificate authority signed certificates for the public facing components, as an example for the web client. It should be noticed that you can decide not to use VMCA as your certificate authority and certificate signer, but you must use VEX to store all vCenter certificates, keys, and so on. ESXi certificates are stored locally on each host and not in VEX. VEX runs on every embedded deployment, platform service controller node, and management node, and holds all the key stores that contain the certificates and keys. vSphere data protection is a feature that was present in vSphere 5, but it saw a few changes. First, let's begin by doing a quick recap of what VDP does. vSphere data protection is a backup and recovery solution for VMware virtual machines that provides easy disk-based backup and recovery for VMware virtualizer environments. VDP uses EMC Avamar variable length segment deduplication technology to minimize backup data storage consumption. Changed block tracking, or CBT, is utilized for backup and restore to reduce time and network bandwidth requirements. VDP is fully integrated with the vSphere web client. So now that we know what it does, let's list the changes that happened between version 5 and version 6. The main change is that now it has agents that enable application consistent backup and reliable recovery of Microsoft SQL Server, Microsoft Exchange Server, and Microsoft SharePoint Server. This includes SQL Server clusters and Exchange Server database availability groups. Individual databases can now be selected for backup and restore, and it is now possible to restore individual Exchange Server mailboxes. Another change is that now vSphere Data Protection Advanced no longer exists, so all the functionalities that it included will all consolidated into vSphere Data Protection 6, and it is available with the vSphere kit anywhere from Essential Plus and up. VMware vSphere replication was another feature that existed before, but that saw a few improvements. Just to give a quick recap of what vSphere replication does. VMware vSphere replication provides data protection and disaster recovery for the vSphere platform by replicating virtual machines within the same site and across sites. It is completely integrated with the web client, and multiple points in time recovery can be enabled to provide as many as 24 recovery points for a replicated virtual machine. vSphere replication can be used as a standalone product or as a replication engine for SRM, or in other words, VMware vCenter Site Recovery Manager, and for VMware vCloud Air Disaster Recovery. So what's new in vSphere 6 for vSphere replication? Well, the main change is that now there is an option to compress the replicated data as it is sent across the network to further improve the efficiency of the replication jobs. It is also now possible to isolate the network traffic associated with replication. This allows the administrators of vSphere to control the bandwidth by configuring more than one network interface card in a vSphere replication virtual appliance, and by using network I/O control to separate the network traffic. The result is improved performance and security. Some changes were made to the way that vSphere replication performs a full synchronization. In the previous versions, vSphere replication requested and compared remote checksums with the local checksums to determine the regions of a virtual disk that had to be replicated. With some storage platforms and vSphere 6, replication can query vSphere for storage allocation information. This is to reduce the amount of time and network bandwidth that it requires to perform a full synchronization. vSphere replication is also fully compatible with VMware vSphere Storage vMotion and both the source at the target locations. Before vSphere 6, moving a replica at the target location required a vSphere replication to perform a full synchronization. With vSphere 6, migrating a replica with vSphere Storage vMotion no longer requires this. Improvements were also made to the VMware tools for the Linux virtual machines. With some Linux OSs, VMware tools features the ability to quiesce the guest OS during the replication and backup operations. With this functionality, enables file consistent recovery of Linux virtual machines. vSAN also saw significant improvements. As an example, now it allows to have a full all-flash architecture, while before you could only use the flash for caching. Also, the support for snapshot was improved. Before, although 32 snapshots were supported in a chain, VMware recommended that only 2 or 3 snapshots were used in a vSAN cluster. vSAN 6 fully supports all 32 snapshots. Performance was also improved across the board. You should expect twice as many IOPS per second in a hybrid cluster, and 4 times as many IOPS supported in an all-flash cluster. Also, the number of hosts increased. In vSAN 5.5 you could only have 32 hosts per cluster. vSAN 6 lets you use 64 hosts per cluster. In vSAN 5 you can only have 100 VMs per host. In vSAN 6 you can have twice as many, so 200 VMs per host. In vSAN 5 you could only have 3200 VMs per cluster. In vSAN 6 you can have 6400 VMs per cluster. Also, the disk size for VMs on vSAN 5.5 was only 2 terabytes. In vSAN 6, it supports all the way up to 62 terabytes. There were quite a few other improvements for vSAN 6, and it would take perhaps too long to go through all of them. In the resources section at the end of the presentation, I have added a white paper that includes all the new and improved features for vSAN 6. So if you're interested in knowing more about this, that would be a good place to start. For last, I will do a brief introduction to the useful resources section that I have added at the end of the presentation. This includes links to documentation and important KBs that will be constantly updated. In this page, I have included a few general useful resources, as an example for installation, and an important one regarding if you're using NSX or vCloud Director presently and you're planning to upgrade to vSphere 6. In this page, I included resources that are specific for vCenter server, as an example the new procedures for stopping, starting or restarting the services. In this slide I added ESXi specific resources, as an example all the hardware devices that are deprecated and no longer supported in ESXi 6.0. And in this slide I added a few general resources that are very useful as well. The first one being the white paper that I used to create most of this presentation, which includes all the changes for vSphere 6. The second white paper includes all the changes and new features for vSAN, which includes quite a considerable amount of features that we weren't able to cover here due to time constraints. And also a couple of KBs, one that covers load balancers and which ones are supported, as well as 2 KPs that cover the new vMotion features to greater detail. Thank you very much for listening to this presentation, and I hope that it was very useful to you and that you learned a few of the new features and changes that happen in vSphere 6.